Alright, grade 9s, we're going to look at solving some inequalities. And we're going to start just using this as a reference guide on how this process works, just quick and easy here. If we're working with 6 is greater than -4, we can alter that a little bit in a bunch of different ways. So we can add 2 to both sides, so 6 plus 2 it becomes 8, -4 plus 2 becomes -2. Now when you're doing that, you keep the same sign, so that is still 8 is greater than -2. This sign doesn't change. Subtracting 2, you can do the same thing. Subtract 2 from 6 and you end up with 4. Subtract 2 from -4 and you end up with -6. And again, the sign does not change. You can multiply by 2 as well. So 6 times 2 is 12. -4 times 2 is -8. And again, the sign does not change. You can divide by 2. 6 divided by 2 is 3. -4 divided by 2 is -2. And again, the sign does not change. So that is fairly easy to deal with. Now, in the instance where you're using -2 to change things instead of +2, it is going to change some things. So let's have a look here. 6 plus -2 is actually 4. And -4 plus 2 is -6. And in this case, again, the sign does not change. And you'll see that it has the same new inequality. It has the same effect as subtracting 2, which adding -2 subtracting 2, logically it's the same thing. If you're going to subtract -2, then 6 minus -2 becomes 8. -4 minus -2 becomes -2, and still the sign does not change. So that's like adding 2. It has the same result. Now, these last two are special cases. When you're multiplying by -2, 6 times -2 is -12. That's fine. -4 times -2 becomes 8. Now, these are special cases. When you're multiplying by a negative number to both sides of your inequality, your sign is actually going to change to the other direction. So instead of greater than, in this case, it becomes less than. Let's have a look at dividing by -2. 6 divided by -2 is -3. -4 divided by -2 is +2. And once again, same deal as multiplying. When you divide by a negative number, you're going to reverse your symbol. So, when you're adding and subtracting a negative, it takes on a similar thing to adding and subtracting the positive number. However, you'll notice that -12 and 8 are not up here. Everything's changed. So these are unique. So by seeing that, we have a rule for multiplying or dividing by a negative, and that is that we reverse the inequality sign. And so it doesn't matter if this starts off as greater than or greater than or equal to, it still gets reversed. So it becomes less than or it becomes less than or equal to. Or vice versa, if we're starting with a less than, it becomes greater than or greater than or equal to, depending on the situation. So that's something, sort of a bit of a cheat sheet for you to reference as we go through this next bit in the chapter. So let's have a look at this. Solving single-step inequalities. And here's our first example. -2 times x is less than 8. We're going to use a model to demonstrate this. Using this inequality, we're going to use blocks. So we've got 2 negative variable blocks on the left. So 2 hollowed out x bars. And on the right, we've got 8 positive tiles. And so we've drawn 8 positive 1 blocks on the right. Now, because it's an inequality, this side is less than this side. And if we're on a scale, If this is less, then it's lighter, and so it's going to be higher up than the heavier side. So 2 negative x blocks on the left and 8 positive blocks on the right, and it's going to tilt with the right side being heavier. Now, for the left side to be less than the right side, each negative x blocks must be less than 4 of the positive blocks. Now we've got 2 and 8, those are both even, so you can separate them into 2 groups. And if you separate them, you can put them on 2 different scales if you want, as long as you do it equally. This is the scenario that you would have. You've got 1 negative x blocks and 4 positive blocks. So one of these must be lighter than 4 of those in order for it to still stay tilted and to have it correct. So negative x then is less than plus 4. So that will be true for every situation where x is actually greater than negative 4. So negative x is less than 4. So if you take a number line and you plot out some possibilities, we'll do a few different options here just to show you how this works. So we've got 1, 2, 3, 4, 5. Here we'll go to negative 5 on this side. If x is equal to negative 5, then negative x would become positive 5, which if you had a positive 5 here, that's greater than 4, so that's not true. That won't work. If x is negative 4, then negative x is positive 4. And positive 4 is not less than 4, it's actually equal to, so that value doesn't work either. Negative 3, if x is equal to negative 3, then negative x is plus 3, and that is less than 4. So that number does work. So that number does work on your number line. So I've drawn a little dot there. Let's have a look at some other numbers here. What if we did 3? If x was equal to 3, then negative x would be negative 3, which is, yes, definitely less than 4. If we said x was equal to 4, then negative x would be negative 4, and again, that's less than. So these points are all good. It's the points down here that don't work. So what we've shown here is that x must be greater than negative 4. So if it's greater than negative 4, we can draw a circle here and then fill this in. So you can test it, and like we kind of just did, test different ranges to see what fits for that if you can't spot it right away. So we've got an arrowhead pointing this way. So anything less or greater than negative 4 will hold true for that. Which means if we've taken, well, let's just keep looking at the rest of this page first. If you look at these, each side has changed its sign. So this negative x became positive, and this positive 4 became negative, which means we've multiplied or divided by negative 1. But the sign reversed directions. So now, instead of having this picture, using this inequality, we can work with this new inequality and draw it, and we can see that x is greater than negative 4. So if it's greater, then it's heavier. Now I am noticing here that as far as integer blocks go, this is positive, so it should have been shaded black, and these are negative, so they should have actually been white. So that's an error in the graphic here, and I apologize for that. But Now x is heavier than the 4 negatives. So when you multiply both sides by a negative number, your sign flips. So the solution to the inequality of negative 2x is less than 8 becomes x is greater than negative 4. And we've now shown that. Now, we can isolate the variable. We can avoid drawing. We can take the original one. We want to isolate the variable, so we're going to divide. This is negative 2 times x. That's the only operation in here, so we're going to do the opposite. We're going to divide by negative 2. Divide both sides by negative 2. These two divide out and becomes just x on the left. 8 divided by 2, negative 2 becomes negative 4. And when we've done that, we started with less than, we're going to end up with greater than. So x is greater than negative 4. So now we've got to show, please go ahead and do that.